Okay, let's try to take a look at their examples in Sage. Now, in looking at the theorem 5.2.1, I solved this, and that's what we're going to start with, but it wasn't quite what we had hoped. Um, we didn't get a nice real part and imaginary part from these. And so, let's take a look at what we can do. And so, I said make z a symbolic variable. Let's just solve z squared equals 1 plus I for z. And then we showed these various things. Oh, I don't want right hand side there. Oh, I see. Yeah, I had played with it a little bit, so I have two of the same command. Let me get rid of that for a moment. And let's evaluate. And again, the problem was that it did plus or minus the square root of I plus 1. And well, so what's the real part of that? What's the imaginary part? I don't know. And so, though, and this is a good reason to be able to do this right-hand side thing and get to just this piece right here. So we're going to say, oh, give us the real part by saying real. And then we'll go here and, and toss in that we want the imaginary part. And again, those are functions, so we need to put parentheses there. But now if I evaluate, then when we go down, we'll see z is the square root. But here is the real part, and here is the imaginary part. And so if I put those two pieces together, that would be the answer. Now, it looks like this might not be real because I see a minus under a square root, but notice it's 2 plus the square root, or sorry, 2 and then minus the square root of 2. Well, the square root of 2 is smaller than 2, so this thing is indeed positive under that square root. Now, so, we can do a little bit more with this. We could try saying simplify, because I got the square root of the square root of 2 and so forth. Let's see if that gets us anywhere. And so I'll just say simplify, and again, it's a function, so I toss in the parentheses at the end. And we can do that and see how that looks. It looks a little better, but I knew that the square root of 2 was 2 to the 1/4. So I don't know that it really bought me too much, but it does look a little nicer here. And now, is that the same value, for the x portion and then the y portion that they got? Good question. Let's see. Now, I'm just trying to look here if, yeah, so if we know x, then y is 1 over 2x, and we could kind of check that up here to see if that was the case. Now, another thing we could do is we could try each of these things numerically. So for instance, I could check 1 plus the square root of 2 over 2 all under a square root numerically with this piece here. So remember, it's plus and minus. This is the minus one. But let's just check, at the end of all this, instead of all that stuff, I'll put an n. Now I could print out both, but that will give me a numerical equivalent. So about, negative 1.0986. Now to compare that, I could simply show, we had it's I think minus, right? So minus the square root of, and I don't remember now, so the square root of 1 plus the square root of 2 over 2. So I can do 1 plus, well, I need another set of parentheses, I guess. 1 plus the square root of 2, all divided by 2. And so then I will, once I do that, I'll take the numerical equivalent, and let's see if these are, they, hopefully they should be, but yeah, so there you go. So see, they are the same thing, and I could check that very easily that way. Other things I could do is I could subtract one from the other and check that it's 0 or something along those lines. But I'm going to get rid of that and get rid of the n here. And then I'm also going to add all this stuff. Well, actually first I'm going to copy that and paste it here, and then toss in that stuff there, and this one here, and evaluate, and hopefully everything works. Yep. So I can get those real and imaginary parts that way, and again, I can always go to the numerical part if I need to. Okay, so that's example 5.2.1. Now if we go down here to 5.2.2, they want to solve z squared plus the square root of 3 plus I times z plus 1 equals 0. So the square root of 3 plus I times z. So I'll just go in here and say, okay, I want the square root of 3 plus I times z, and then that was plus 1 equals 0. And so I would like to solve that. Oh, I forgot my plus here. Okay, so I would like to solve that equation and do all these same things with it, and so I'll evaluate. And so it says the one of the solutions, the real part. Now this one, oh no, there's a square root of 2i there. So notice again, it gave a pretty funky answer here with having an I under the square root and all that. But so here it says the real part is the negative of square root of 3 over 2 plus 1/2. And then the imaginary part is the same thing. So is that one of the answers they got? They went through and no, let's see. So they say, oh wait, well no, I was going to say, oh wait, no, they got the same thing we did, but no, they have 1 minus the square root of 3 over 2 plus 1 plus the square root of 3i over 2. And we don't have a 1 in there. Now I'll have to go back and make sure I set up the problem right, but let's look let's look at the problem again. Square root of 3 plus I, z squared, square root of 3 plus I times z plus 1 equals 0. Z squared plus the square root of 3 plus I times z plus 1 equals 0. Solve that for z. Okay. And so we are getting, I think we're getting a different answer. Oh no, there's the minus. Oh yeah, okay, what did I say? Square root of 3 see, not good with numbers. So take the minus out, and then I've got the square root of 3 plus 1 all over 2. Yes, that's what they have. Sorry about that. Yes, we have those same answers. So we're looking at this answer. Okay, so the minus on both of those and all over 2, and then we should have minus on both of the others, so they should look the same. And then the other one, I should just have a negative on the square root of 3. So if we go back here and look, those had negatives on everything. This had a negative on the square root of 3, and then a plus 1/2. And then this has, what, a plus square root of 3 and a minus 1/2? Is that what they had? They have a plus on both. Interesting. I'm going to go with, since we've got exactly what they have there, and we have exactly what they have here, I'm kind of wondering if they have a typo here on their 1. I think maybe that might be wrong. Now, a way to check that is we could take their number and put it into the original equation and see what we get. Okay, I am not going to take the time to do that, but that is what I would do, and I may do it outside of the video, but you can do that. Okay, so then find the cube roots of 1. And here what they do is z cubed equals 1, and then they subtract the 1 and turn it into a linear term, which, yeah, we can solve that very easily. Z is 1. And then this quadratic term that they solve for the quadratic thing. Well, let's try just solving z cubed equals 1. So I'm going to go up here and make that z cubed, and then like they have, I'll do minus 1. Now we're going to get 3. We should get 3 answers, right? So I'm going to copy all that and paste it, and then just put a 2 in here, and hopefully it will all work. It's starting out that way. And so here what's nice is when it gave us the roots, we didn't really need to do the real and imaginary part. I see it's minus 1/2 and then a square root of 3 over 2i plus that, and then the complex conjugate, so it's minus 1/2 and then plus or minus the square root of 3 over 2i and then 1. And I think that is what they show here. Yep. And so you know, we can just go to Sage and solve that z cubed equals 1. You know, so if I wanted to change it to something even a little nastier, how about z cubed minus how about I times z and plus 1, just to see what the heck happens. Go down here and evaluate. Whoa, that's kind of big. So we got a bunch of stuff, but yeah, it's kind of long. Wow. You know, so I could make this much smaller font and so forth, and try to look at the whole thing. But there you go. So it was able to solve this cubic equation with complex coefficients and in no time at all. So Sage is a pretty wonderful thing. And so those are our 3 examples, and we'll stop there.